Dear students, in this session we will see class 11 chemistry number 89. The topic includes here state structure of atom, topics from particle nature and Planck's quantum theory and photoelectric effect. What we need to discuss briefly, 2 minutes we will see present class what we have to discuss. Particle nature we need to discuss. Particle nature. Here three concepts in this class. One is particle nature. Previous session we completed wave nature. Wave nature of particles, electromagnetic wave like that. And particle nature which describes about certain theories and laws. So those includes that Planck's quantum theory and also photoelectric effect. These two we can discuss in this especially. So Planck's quantum theory, Planck's quantum theory. What are those we need to study under this heading? So any definitions are there? Next formulas and units and then calculations and assumptions. First we need to see assumptions also. What are assumptions taken for particle nature and also Planck's quantum theory we need to study. So here next one, coming to the photoelectric effect. Photoelectric effect. What is the meaning of photoelectric effect? Here there is definition and explanation and how that photoelectric effect we can say conditions and then observations. Then how photoelectric effect is explaining dual nature of its rays. Dual nature of light is explained by photoelectric effect. How means we need to explain. And here while discussing with particle nature and Planck's quantum theory, we need to explain black body also. Black body radiations. What are black body radiations? What are assumptions related to black body? Now these are all the topics we need to study in present class. So what we need to study means first concept particle nature. So previous class we studied wave nature, electromagnetic radiation, wave nature, and the different types of characteristic features of electromagnetic radiation we completed. Now here present class particle nature, Planck's quantum theory and photoelectric effect. What we need to study about particle nature? So what are the various theories proposed for particle theory or particle nature of the light and also black body radiations? What we need to study about black body radiation? What is the definition of black body radiation? What are the characteristic features? How to prepare black body? And what are the conditions for the black body radiations? And coming to the Planck's quantum theory, what the theory definition and assumptions, any formulas or units and calculations are there we need to. In board exams as well as object examination, the questions can be calculated based on Planck's quantum theory. Next, coming to the photoelectric effect. What is photoelectric effect? How that the photoelectrons are emitted and the procedure for explanation and conditions and observations, and how photoelectric effect will explain the dual nature of light we can discuss in this class. In this class we are going to deal about these three concepts including NCERT book by questions based on this concept and also worksheet questions we can see. Now first particle nature. The important points related to particle nature of light and also black body radiations with the notes we can see here. Now here we will see a brief outline regarding electromagnetic radiation dual nature. So, electromagnetic radiation dual nature is possessed. The dual nature is nothing but both wave nature and particle nature. In this class, we are going to see particle nature because already we have seen wave nature. Wave nature explains diffraction and interference phenomenon. Diffraction and interference phenomenon is explained by wave nature, but not by the nature of emission of radiation from hot bodies is not explained by wave nature, and also ejection of electrons from the metal surface is also not explained by wave nature, and then variation of heat capacities of solids as a function of temperature is also not explained by wave nature, and last one, line spectrum of hydrogen is also not explained by wave nature. Wave nature only explains diffraction and interference concepts. We know that diffraction means bending of wave around an object. When light is passed through an object or obstacle, so automatically light will be bent. That wave will be bent. That is nothing but the process is called diffraction. So at a certain angle is called as diffraction angle. That is a different concept. That is explained by wave nature, and interference also explained by wave nature. So what is interference means? Merging of two waves or two waves in superpose automatically results in a different wave which has lower or higher or same magnitudes or amplitude. You can write. Amplitude will be the same or higher or lower than individual one. That nature is explained by wave nature of electromagnetic radiation. When a light of two different waves are superimposed, then automatically results in a new wave that has either different or same or lower or higher amplitudes. Amplitude is nothing but which decides the intensity of radiations, we know that. Now, the particle nature explains the failures of wave nature. Wave nature does not explain all those. So, wave nature is not explained all these four parameters. These four parameters are explained by particle nature. What are those means? First one, nature of emission of radiation from hot bodies. That is nothing but black body radiations. That is nothing but black body radiations. Black body radiations. While explaining black body radiations about the photons energy is discovered by Max Planck quantum theory. Max Planck's quantum theory. So, Max Planck's quantum theory. These two are explained in particle nature, we can write. And next, ejection of electrons from a metal surface, other name is called as photoelectric effect. Photoelectric effect. Photoelectric effect. And then variations of heat capacities of the solids as a function of temperature. This will be learned in thermodynamic principles. Thermodynamic principles. Next, line spectrum of hydrogen. It is also explained by particle nature. We can write Bohr's spectrum. Bohr's spectrum. Now, in this present class, we need to study about the particle nature, that includes black body radiations and Max Planck quantum theory and photoelectric effect. Now, we are going to study in this class. Now, first we will see what are black body radiations, how they are produced, what are the characteristic features of black body radiations, and any graphical representation for black body radiations with respect to temperature we will see now. Now here in this class we need to see particle nature, especially with the black body radiation and Max Planck quantum theory, and then photoelectric effect. Now we will see one by one. with notes and explanation. Now here, an important information related to black body radiations. How the question will be asked in CBSE examination. We can write explain black body radiations or what are black body radiations, give examples and explain how black body radiations are affected by temperature with their frequencies. This is the type of question can be possibilities are there in CBSE examinations. Now we will see what are black body radiations. Black body radiation means from the name itself we can get the radiations which are emitted from a black body are called as black body radiation. Then what is a black body means? It is not meaning of black colored body. Black body means it is nothing but ideal substance or compounds or ideal thing that can emit and absorb all type of frequencies of radiations. An ideal body which absorbs and emits radiations of all frequencies are called as ideal bodies, or we can write black bodies. Black body means what? These are ideal bodies which can absorb and emit all type of frequency radiations. So here we can write how much amount of absorption, rate of absorbed must be equal to rate of emission, we can write. So suppose they can absorb some amount of light means they also can able to chance to emit the radiations. So those type of bodies are called black bodies. There is no ideal black body in the universe, we can write, but we can make very near black bodies we can make. So examples we can write, and the radiations which are obtained from black body are called as black body radiations, we know that. Now how to get the near acting black body means, suppose example a hollow sphere if you take a hollow sphere and it is coated inside with platinum black. This is coated with platinum black we coated, and here made a circular holes in that holes, so which will be act as a black body, because the rate of absorption is equal to emission. Also we can write it absorbs, this body absorbs and emits all type of radiations of frequencies. All type of radiations we can get. All type of radiations we can get. This is nothing but black body we can write. Next another one. When white light is going to be produced when hot flame in the light bulb. So that is also an example for ideal body which can absorb and emits all type of frequency radiations we can write. Those are considered to be black body radiations. Now the effect of temperature on black body radiations are over their frequencies. Intensity of light, we can write intensity of radiation emitted increases with and reaches to the maximum and then decreases. If you observe the curve plotted between wavelength on x-axis and frequency of radiation on y-axis, this curve is called as a frequency distribution of radiation curve, we can write. Frequency distribution of black body radiation curve, we can write. The black body radiations, the wavelength related and the frequency curve is called as frequency distribution curve. If you observe the frequency distribution curve, it is affected by temperature. At T1 temperature or T2 or T3, irrespective of the temperature, first the frequencies goes to the maximum and reaches highest, and then decreases to short wavelength. That means intensity of radiation emitted is directly proportional to the temperature up to certain extent, and then inversely proportional to the temperature after that extent. That means we can write here gradually the lambda will increase and then the lambda will be decreasing gradually. That is the point we can write. As temperature increases, the maximum intensity shifted towards a shorter wavelength. The maximum intensity shifted to the shorter wavelength. This is called maximum intensity, and it is going to be shifted to the minimum wavelength or shorter wavelength we can write. Next important point, energy of radiations. From the blackbody radiations, one can able to say energy of radiation is emitted in the form of discrete packets. Discrete packets such as called as quanta, and this energy is also called as photons. This energy is also called as photons as the multiplication of integer values. N 1, 2, 3, 4, 5. Photons is nothing but h nu. There the h value is called as Planck's and the Planck's quantum theory we are getting here. Max Planck's quantum theory. Max Planck's quantum theory. Now the term gets in Max Planck quantum theory. And here temperature relation T2, T3 greater than T2 greater than T1 we can write. Now this is about blackbody radiations and discovery or resulting of Planck's quantum theory we completed now. Now what is blackbody radiation? Blackbody radiation means the ideal body which can absorb or emits all type of frequencies of radiations are called blackbody. That radiation so produced from blackbody is called blackbody radiations. How to obtain blackbody? A circular hollow cube made inside coating with platinum black and made the holes inside the platinum hole at the walls. Then it will be acts as a blackbody radiation mechanism because it can absorb and emits all type of radiations of all frequencies. And one more point, another example for blackbody is we can write white light emitted by heating or hot flame in light bulb. That also acts as another blackbody example. And the intensity of radiations emitted by blackbody is directly proportional to temperature and increases up to certain extent and reaches maximum. Then it decreases to shorter wavelength we can write. If the curve plotted between wavelength on x-axis and frequency on y-axis with effect of temperature, the frequency distribution of radiations we can plot and it results that up to certain extent increase in temperature, the wavelength and the frequency also increases we can write. After reaching the maximum extent, then the wavelength decreases or the curve will move towards a shorter wavelength upon increase in the temperature. That is the point we can observe here. And here, if you observe the energy of radiation which is emitted or absorbed is present in the continuous form and discrete packets. Continuous discrete packets. That is called as quanta. That is called as quanta, or also called measured in terms of photons. That is nothing but h nu, where h is the Planck's constant and e is the velocity of the frequency of the light or radiation we can write. Now we can write Max Planck quantum theory is going to be discussed here. Next concept is Max Planck quantum theory. What do we need to study about Max Planck quantum theory? The definition and the statement and then explanation, mathematical formula, units and measurement, and the significance and applications. Now we will see Max Planck quantum theory. In subject examinations, they will ask about what are blackbody radiations, explain. 2 marks or 3 marks. Next, represent graphically about the blackbody radiations with temperature and the frequencies. Frequency distribution curves also they will ask. Frequency distribution curves. Now we will see Max Planck quantum theory. Now here, Max Planck quantum theory. Max Planck's quantum theory. He explains particle nature of light. Particle nature of lighter, and also energy of radiation, especially black body radiations, absorbed or emitted is in the form of discrete packets, which are called as quantum, So there is nothing but his statement we can write. So that's why E is directly proportional to, we can write a new frequency. And he proposed an expression to calculate the relation between energy of radiation and the frequency of radiation. At constant temperature, energy is directly proportional to frequency of radiation, we know that. Now a proportional constant introduced to establish a proportional relation to equal proportion is equal to E is equal to h nu, we write. What is E means? Energy of radiation. Nu means frequency of radiation, and h means Max Planck quantum theory. Max Planck's quantum number. Max Planck's quantum constant we can write. Constant. Max Planck constant we write. H value we know that H value we can write 6.627 into 10 to the power of minus 34 joule second, or it is also equal to 6.627 into 10 to the power of minus 27 every second. Or this value can also be written as 3.99 into 10 to the power of minus 13 kilojoule per mole. 3.99 into 10 to the power of minus 13 kilojoule per mole also we can write. So this is the value of Planck's constant we can write. The Planck's constant he proposed by Max Planck in the quantum theory. Now here the relation between Max Planck quantum theory with energy and frequency and wavelength relations. Now here we have three formulas. E is equal to h nu, or nu is equal to, we know, C by lambda, or nu is equal to, we know, C nu bar. Then we can write an expression for modifications. E is equal to h nu 1, or E is also equal to hc nu bar, or we can write E is equal to hc by lambda also we can write. hc by lambda we can write. Now from here one can draw the information E is directly proportional to nu. That means energy increases, frequency also increases. E increases, that means frequency also increases, we write. Now here in the second case, E also directly proportional to nu bar. As Planck's constant and velocity of light both are constant, so E is directly proportional to nu bar means as energy increasing, so wave number also increases. Now in the third expression we see E is inversely proportional to lambda, because Planck's constant is constant, velocity of light also constant. So the relation between energy and lambda is inversely proportional. So that means energy increases, lambda decreases, you can write. Decreases in wavelength. Increase in energy, wavelength will be decreases. These are the various phenomenon given from Planck's quantum theory, Max Planck quantum theory. These are the various related problems can also be asked. So here h value we know that h value is equal to 6.627 into 10 to the power of minus 34 joule second, or 6.627 into 10 to the power of minus 27 every second, or we can write 3.19 into 10 to the power of minus 13 joule per mole. We can write all those values and we can substitute. We know that the value of C is equal to 3 into 10 power 8 meters per second or 3 into 10 power 10 centimeter per second also we can write. So with the help of this energy, wavelength and energy and also frequency and energy and wave number relations based problems also we can see. Now energy per mole in gas means energy is equal to Hc by lambda into 1 by Avogadro's number we can write. 1 by Avogadro's number we can write. Energy per molecule of gas means. Energy per mole means we can write energy per molecule. Energy per molecule. Now energy per mole of gas means per mole. 1 mole containing Avogadro's number. No? So Hc by lambda into Na we will write. These are the various types of problems can be come in a competitive examination, sir. Chance is there maximum. This completes the Max Planck quantum theory. Next we will go for photoelectric effect. Next we will go for photoelectric effect. Now in Max Planck quantum theory, what do we read? What is the statement given by Planck's quantum theory and what is the expression given by Planck's quantum theory? And then what are the related problems can be chance in asking competitive examinations and various formulas which relates the energy of radiation and frequency and also wave number with wavelength parameters. Now we will see photoelectric effect. After photoelectric effect we can go for worksheet solving problems with NCERT examples. Now here the last concept in this class photoelectric effect. What is photoelectric effect means? From the name indicates you can write photoelectric effect. So that means when a light of certain frequency, radiation bombarded with a metallic surface. Suppose I take a metallic surface is this. When a light of certain frequency radiation nu is bombarded or strikes with a metallic surface, it ejects some electrons. We can write. So because of oxidation process, as metals have tendency to lose electrons. So when a radiation of frequency of radiation is nu hits or strikes with a metallic surface, it will eject some electrons. That phenomenon is called as photoelectric effect. And that ejected electrons are called photoelectrons. Here the same representation we are doing here. Suppose a detector can identify how many number of electrons are coming with the help of the energy generated in ammeter. How much ampere is going to be generated, which is connected to a battery in a vacuum chamber. Here we are placing a metallic surface and a white light in a light of radiation with a frequency nu is strikes with a metal surface. It ejects some electrons. That electrons which are liberated, which is measured by a detector. The number of electrons emitted is called as photoelectrons. The number of electrons emitted are called photoelectrons. This effect is called as photoelectric effect. Now we will see what are the postulates and observations related to photoelectric effect. First point you can see ejection of electrons from surface of metal when light of suitable frequency strikes. The same point we discussed here. We can make it note there as a notes. Now, ejected electrons are called photoelectrons. Now here, the minimum amount of frequency required to eject electrons or for photoelectric effect is called as threshold frequency. What is the meaning of threshold frequency? It is a minimum frequency. Minimum frequency possessed by light. Minimum frequency possessed by light to detect the electrons when it strikes with the metal surface. That is indicated by mu naught. That is indicated by mu naught we can write. Now here, so minimum energy is called threshold energy. Threshold energy. So threshold energy is the minimum energy, or it is also called work function. It is also called work function, denoted by W, that is equal to H naught, H nu naught. Now we can say here third point. Minimum frequency required to eject photoelectrons or produce photoelectric effect is called a threshold frequency. It is represented by mu naught. If nu is the frequency of light, mu naught is the threshold frequency. Now, minimum energy required is called work function, denoted by W, that is obtained by multiplication between Planck's constant and mu naught. So that is called work function. Now next, the number of photoelectrons emitted is directly proportional to intensity of incident light. The number of photoelectrons emitted. Here the number of electrons emitted is depends on intensity of incident light. Intensity of incident light. What is intensity definition? It is represented by power produced by per unit area. Power produced per unit area. So that means maximum power is given means maximum number of electrons can be ejected. So here the kinetic energy of photoelectrons depends only on frequency of incident light but not intensity of the incident light. This is very much important point. Number of photoelectrons emitted is depends on intensity but not potential energy of emitted electron. Potential energy of emitted electron depends on frequency but not intensity. Here 2 points you need to remember that. Number of electrons ejected from photoelectric effect directly proportional to intensity of incident radiation. But whereas kinetic energy does not relate with the intensity of incident radiation, but it depends on frequency of radiation. Frequency of incident radiation. Now, suppose example, the relation between frequency of incident light and threshold frequency. If frequency of incident light is greater than threshold frequency, then only photoelectric effect can be possible. Photoelectric effect can be possible when frequency of incident light is greater than threshold frequency. If frequency of incident light is less than threshold frequency, there is no effect of photoelectric effect. There is no photoelectron charge. There is no photoelectron charge. And one more important point here, the metal which is used here generally all three metals. All three metals you can write. Example, potassium, rubidium, cesium can be best metals you can write. Now another important information, stopping potential. What is a stopping potential means the minimum potential at which photoelectric current is zero. The minimum potential at which photoelectric effect is zero, that potential is called stopping potential. Now here what the terms we have? First one, frequency of incident light. Second one, threshold frequency. Third one, work function, that is equal to H nu naught or threshold energy also we can call. And also next, stopping potential. And also stopping potential. And kinetic energy of the photoelectron ejected one. Now this is nothing but a photoelectric effect. Photoelectric effect means we know that the effect produced by when a light of radiation of frequency is strikes with a metal surface, it ejects some amount of electrons. That prevalent electrons is called photoelectrons and the effect is called photoelectric effect. The emitted number of electrons are directly proportional to intensity of radiation of incident radiation. But kinetic energy does not depend on intensity of incident light, but it depends on frequency of incident light. So minimum amount of frequency required for photoelectric effect is called threshold frequency. Minimum energy required for ejection of electrons from photoelectric effect is a threshold energy. It is also called work function, denoted by W, and it is obtained by multiplication between Planck's constant h into nu naught. Now last one, stopping potential. What is stopping potential means? The minimum potential required for the photoelectric current becomes zero. That is called as stopping potential. Now we will see mathematical expressions for photoelectric effect and the formulas related to the photoelectric effect. After that we will see the problems in NCERT based and also worksheet. Certainly questions will be asked from photoelectric effect. What is threshold frequency? What is threshold energy? What is stopping potential? Definitions they will ask. Mathematical formulas also. Here the mathematical representation for photoelectric effect we will see. Photoelectric effect, the relation of kinetic energy of photoelectron and frequency of radiation is correlated with the help of the total energy of photon electron ejected is equal to the work function and the kinetic energy of the emitted electrons. So the net work present in photoelectric effect, the total work is equal to h nu is equal to work function plus that means work function means the amount of energy required to eject electrons plus the work done for the kinetic energy of the electron we can get. So this is about kinetic energy we can get. Now h nu is equal to, nu is nothing but frequency of incident light. H is a Planck's constant. Nu naught means what? Frequency, threshold frequency we write. H is a Planck's constant we write. M is the mass of electron, P is the velocity of electron which is ejected in the photoelectric effect. Now kinetic energy I will take separate. Then what we will get? Half mv square. So here nu naught will get and nu minus nu naught will get. So always nu must be greater than nu naught, then only kinetic energy will exist or photoelectric effect will exist. Photoelectric effect will exist. Suppose nu is equal to nu naught, threshold frequency is equal to frequency of incident light, then K becomes 0. K becomes 0. Suppose incident light frequency is less than threshold frequency, then no photoelectric effect observed. No photoelectric effect observed we can write. This various important information which you can get here. So here from that velocity of electron also we can get. Velocity of electron is equal to, velocity of electron is equal to, we can get a square root of 2 into h into nu minus nu naught divided by m we can write. Divided by m we can write. So this is a formula we can able to substitute here. Now we know that nu naught is equal to nu is equal to c by lambda I write. Nu naught is equal to c by lambda naught I write. Next we will write the expression for velocity of electron is equal to square root of 2 into hc into 1 by lambda minus 1 by lambda naught divided by m we can write. Or we can also write the square root of 2hc by m into lambda naught into lambda naught minus lambda. This is also the formula we can able to write it. We can able to write. Next, how photoelectric effect will express the dual nature of light means we take two equations which explains wave nature and particle nature. Planck's constant equation E is equal to h nu. Einstein equation, we know that E is equal to mc square, where E is the energy of the light radiation, H is the Planck's constant, and mu is the frequency of light, where C is the velocity of light, M is the mass of electron. Now, energies both we can get equalized here. So h nu is equal to mc square is equal to hc by lambda we can write. Now, lambda we can get with this expression, lambda is equal to h by mc we write, where mc is nothing but we can write momentum. Momentum is nothing but mass into velocity. So that is called as momentum. So P is equal to mc, that is momentum of electron, means it is nothing but particle nature. It explains a particle nature. Now hc by lambda, nu is equal to, we know that c by lambda. That means what? It explains wave nature. So dual nature of a light is explained by photoelectric effect we can write. So this completes the mathematical expression on dual nature of photoelectric effect and kinetic energy, how it is related to the threshold frequency and frequency of incident light, and the variations we can observe here. Now we will see NCERT in-text questions and book bag questions based on the topic photoelectric effect, Planck's equation, and the particle nature of the light. In NCERT book bag questions and then exercise questions and then worksheet problems we will see. Now the problems based on these topics are given in NCERT we will see. In text questions, NCERT in text questions we will see now. Question number 2.6. Question number 2.6. Calculate the energy of 1 mole of photons of radiation whose frequency is 5 into 10 power 14 hertz given. Calculate the energy of 1 mole of photons. We know that 1 mole of photons they asked. So here energy is equal to h nu. For 1 mole of photon, we need to multiply with Avogadro's number, Na into h into nu. What is Na? Avogadro's number 6.022 into 10 to the power of 23 into Planck's constant 6.627 into 10 to the power of minus 34 joule second into frequency given 5 into 10 power 14. Calculate and get the answer. You will get the answer 199.508 kilojoules per mole. Kilojoules per mole we will get. Next question number 2.7. Question number 2.7. A 100 watt bulb emits monochromatic light of wavelength 400 nanometer. Calculate the number of photons emitted per second by the bulb is. We know that here 100 watt bulb will emit 100 joule energy. Suppose let x will be the photons, x will be photons emitted from the bulb. Then what about energy is equal to x into hc by lambda we can write. hc by lambda we can get. Energy how much given? Energy is equal to 100 joules. Next, h you know that 6.627 into 10 to the power of minus 34 joule second, and we know that c value, velocity of light 3 into 10 power 8 meters per second, and then lambda value 400 nanometers. 400 into 10 power minus 9 meters. 10 power minus 9 meters. From that we can calculate x value. X is equal to E into lambda by hc. E value how much given? 100 joules into lambda value 400 into 10 power minus 9 divided by H value 6.627 into 10 power minus 34 into what is the value 3 into 10 power 8 will write. Now upon calculation we will get 2.010 into 10 to the power of 20 number of photons. So this answer for this question. If you are able to know that the formula to be used is E is equal to x into hc by lambda, then you can find the number of photons emitted or ejected. So this completes question number 2.7. Now we will see question number 2.8. Next question number 2.8. 2.8. When the electromagnetic radiation of wavelength 300 nanometers falls on the surface of sodium, electrons are emitted with kinetic energy of 1.68 10 to the power of 5 joule per mole. What is the minimum energy needed to remove an electron from the sodium? What is the maximum wavelength that will cause a photoelectric effect to be emitted? Now here, what the information we given, wavelength of incident radiation is given, kinetic energy of photoelectrons are given. What is wavelength of incident radiation? Wavelength of incident radiation, lambda is equal to 300 nanometers given. That means 300 into, we need to convert into meters. So 10 power minus 9 meters. And also they given kinetic energy of photoelectrons. K is given also, that is nothing but 1.68 into 10 to the power of 10 to the power of 5 joule per mole is given. Now here, energy of 1 mole of photons is equal to E is equal to N Avogadro's number into hc by lambda. We know this formula. Now this is nothing but the energy required, that is photon. Now calculate y value 6.022 into 10 to the power of 23 into 6.627 into 10 power minus 34 into 3 into 10 power meters from 8 divided by lambda. What is lambda value? 300 into 10 power minus 9 we can write. Now 3 will be cancelled, 6 3.6. Approximately the value will become 3.99 into 10 power 5. We can get 10 power 5 we will get 10 power 5 joule per mole we will get. Now here, what the energy, kinetic energy of the photoelectron is given and energy of the photon is given. Now threshold energy we can get. Threshold energy E is equal to, we know that Ke plus W. Now threshold energy W is equal to E minus Ke add right. What is the value? 3.99 into 10 to the power of 5 minus 1.68 into 10 to the power 5. So 10 to the power 5 will take common. 3.99 minus 1.68 will get 2.31. 2.31 into 10 to the power of 5 is equal to W. That means minimum amount of energy required to eject electron or photoelectric effect is called threshold energy, and it is equal to 2.31 into 10 to the power of 5 joules per mole we write. Now another question what they ask to find minimum. What is the wavelength of photoelectron emitted? What is the wavelength? We know that E is equal to hc by lambda. So we know that lambda is equal to hc by E we will write. Lambda is equal to hc by E we will write. So what is h means? Planck's constant 6.627 into 10 to the power of minus 34 into 3 into 10 to the power 8 divided by what is the energy of photoemitted electron means 3.99 into 10 to the power of minus 9 we will get. So total value we can get 517 into 10 to the power minus 9 meters, that is equal to 517 nanometers. Minimum wavelength required to eject photoelectrons means 517 nanometer. Here the question is based on photoelectric effect. The formula for photoelectric effect is A is equal to KE plus W. They ask you to find the work function. First we need to find the E value with n number of modes of the electrons. Kinetic energy they given and lambda wavelength also they given. Now we need to find first E value, then find the W value, then find the lambda value again. So lambda naught is nothing but threshold wavelength you can write. So this completes the question number 2.8. Next book back questions we will see. Book back question 2.9 question. Question number 2.9. Another in-text question 2.9 also relates to photoelectric effect. Question number 2.9. Threshold frequency mu naught for a metal is given 7 into 10 power 14 per second. Calculate the kinetic energy of electron emitted when radiation frequency nu is equal to 1 into 10 power 15 per second hits a metal. Now threshold frequency is given, nu naught is given. How much nu naught is given? 7 into 10 power 14 per second. Nu is given how much? 1 into 10 power 15 means I'll write 10 into 10 power 14 second inverse I'll write. This is a nu. We know that formula for threshold, formula for photoelectric effect is nothing but h nu is equal to h nu naught plus Ke. H nu naught plus Ke. They ask to find calculate kinetic energy. Kinetic energy is equal to, we write h nu minus h nu naught. I will common h into nu minus nu naught. H value 6.627 into 10 to the power of minus 34 into nu value how much given? 10 into 10 power 14. 10 power 14 I will take common, 10 minus 7 that is equal to 3. I write 3 into 10 power 14 I write. So total 3 6 are 18. So approximately the answer will become 1.9888 into 10 to the power of minus 19 joules you can get. So question number 2.9 is completed. So with this in-text questions are completed. Next we will go for book back questions we will see. Book back questions we will see. Next inside the book back questions we will see. Exercise questions. Here exercise number question number 2.6. Find the energy of each photon which corresponds to the light of frequency 3 into 10 to the power of 15 Hz has wavelength 0.50 angstroms. We know that the formula to calculate energy when frequency is given means E is equal to h nu. This is the first problem. Second problem, when wavelength is given, how to calculate energy? E is equal to hc by lambda. H value we know that 6.627 into 10 to the power of minus 34 joule second. So both cases we can use a constant value. C we know that 3 into 10 to the power 8 meters per second. So nu value in first problem is given how much? 3 into 10 power 15, 10 power 5 adjust given, 15 adjust given. Now we can find out E is equal to h nu and we will get the answer approximately 1.978 into 10 to the power of minus 18 joules you can get. In the second case, use this formula, U is equal to hc by lambda. We will get the value approximately 3.975 into 10 to the power of minus 15 joules. You can substitute and you will get the answer easily. Lambda value how much given in this problem? 0.50 angstroms is given. 1 angstrom is equal to how much centimeter? We can write 10 to the power of minus 8 centimeter, 10 to the power of minus 10 meters we know that. Now substitute these values and you will get the answer 3.975 to 10 to the power of minus 15. Next question number 2.8. Question number 2.8. What is the number of photons of light with a wavelength of 400 picometer that provide 1 joule of energies? Now here we need to use the formula E is equal to x into hc by lambda vector by. So 1 photon they given. So we have to calculate x value. So x is equal to, we know that E into lambda by hc. E value given 1 photon. Lambda value how much given? 4000 picometer. Lambda value 4000 picometer means 4000 into 10 power minus 12 meters divided by h value 6.627 into 10 power minus 34 into velocity of light 3 into 10 power minus 8 meters per second. Calculate how much you will get means approximately 2.012 into 10 to the power of 16 quanta will get. The same formula we are using in solving the in-text question also. Next question number 2.9. A photon of wavelength 4 into 10 power minus 7. Lambda is given 4 into 10 power minus 7 meters. Strikes a metal surface of work function. W is given 2.13 electron volt. Calculate the energy of photon in the electron volt, kinetic energy of emitted electron, velocity of photoelectron. So here 3 problems they asked at a time. So E is equal to hc by lambda, we know that. What is h value? Planck's constant 6.627 into 10 to the power minus 34 into 3 into 10 power 8 divided by what is lambda given? 4 into 10 power minus 7 meters only given. So we can substitute directly and we will get the answer. So we can get 3.1 volt. 3.1 electron volt we will get. So conversion factor we need to use here. Division of 1.6 into 10 power minus 19 we can use to convert it into electron volts. This fraction will come in joules. This fraction will come in joules. So joules should be converted into electron volts means we need to divide with this factor coulombs of electricity. 1.6 into 10 power minus 19. So first one will be answer 3.1 electron volts. What the second one they asked to find? The second one kinetic energy they asked. Kinetic energy is equal to E minus E naught we will write. That means work function. E minus W will write. So what we can get the E value how much? E value 3.1 and work function they given 2.13. Then upon calculation we get 0.97 electron volts. Is the kinetic energy once you can get. Now velocity of electron means third one. We know that the velocity of third K is equal to 1 by 2 mv square is equal to 0.97 electron volt. Now V is equal to square root of 2 will go that side. 2 into 0.97 divided by mass of electron will get. Mass of electron will get. So we can get approximately answer 5.84 into 10 to the power of 5 meters per second will get. Meters per second will get. So once you know that energy, then we can get kinetic energy, then we can go for velocity. All are linked one only. All are linked one only. If you are able to solve this problem, what kind of problem given in a competitive examination also, you can solve easily. This is a phenomenon how they will give NCERT book back questions. All are linked only. One question you got means we can substitute the value in the next question. After that another question. So that we completed 2.9 question. Question number 2.9 is completed. Next one 2.10. Question number 2.10. Electromagnetic radiation of wavelength 242 nanometer is just sufficient to ionize a sodium atom. Calculate the ionization energy of sodium in kilojoules. So lambda is given here. Lambda how much given in wavelength? Wavelength is given 242 nanometer. 242 nanometer. That is equal to 242 into 10 power minus 9 meters will write. 10 power minus 9 meters. We know that ionization energy given for mole. That means we can write Na into Hc by lambda we can write. What is our number? 6.022 into 10 to the power 23 into Planck's constant 6.627 into 10 to the power minus 34 into velocity of light 3 into 10 power 80 divided by lambda 240 into 10 to the power minus 9 will write. Upon calculation we will get 496.4 kilojoule per mole will get. So this also a problem can be asked in a competitive examination by creating some options. So you need to be thorough with this formula. Once you know the formula, you can able to solve the answer. Next question number 2.11. Question number 2.11. Here a 25 watt bulb emits a monochromatic yellow light of wavelength 0.57 micrometers. Calculate the rate of emission quanta per second. Here energy release per second is given. Energy released per second is equal to 25 joules is given. Next wavelength of light is given 0.57 micrometers. Micrometer means we know that conversions I given in the synopsis point 10 power minus 6 meters. Our velocity of light we know c is equal to 3 into 10 power 8 meters per second we know that. Now energy of photons we know that formula E is equal to x into hc by lambda. Now x is equal to E lambda by hc we can write. What is energy given? 25 into what is lambda? 0.57 into 10 power minus 6 divided by what is velocity of light? 3 into 10 power 8 into Planck's constant 6.627 into 10 to the power minus 34. Upon solving, we will get x value 7 into 7.1688 into 10 to the power of 19 quanta per second we can get. This is the answer for this question. Already we have solved this type of question in text questions. Next question number 12. Question number 12, 2.12. Electrons are emitted with zero velocity from a metal surface when it is exposed to radiation of wavelength 6800 angstroms. Calculate the threshold frequency and work function W naught of the metal. Here, two problems they ask you to find. So now here we know that h nu is equal to h nu naught plus Ke at light. Now here what they ask you to find? Work function and threshold frequency they ask you to find. So kinetic energy of photoelectrons is what they given? 0. Velocity is 0 means 1 by 2 m v square also becomes 0. Ke is also becomes to 0. So that we can write h nu is equal to h nu naught. We need to calculate first nu naught. But they are not given nu. They given lambda. So we write hc by lambda is equal to h nu naught. So h will get cancelled. Nu naught will get c by lambda will get. What is c value? 3 into 10 power 8 meters. What is lambda given? What is lambda given? Lambda given wavelength given 6800 angstroms. 6800 into 10 power minus 10 will write. So we can get threshold frequency 4.41 into 10 to the power of 14 hertz approximately. Now here we know that work function is equal to h into nu naught. H value 6.627 into 10 to the power of minus 34 into nu naught value 4.41 into 10 to the power of 14. We will get approximately minus 20 the values 6 words are 24. So we can get approximately 2.93 into 10 to the power of 10 to the power of minus 19 will get. 10 to the power of minus 19 joules will get. Minus 19 joules will get. So this completes the NCERT book bag questions and also in text questions. Now we will see the worksheet questions based on the topic work function and kinetic energy or photoelectric effect and Planck's quantum equation. Now here we will see the class level worksheet for 8-9 class. The problem is based on the present topic. Here first question, the small packets of light is called photon. It is a theory question only. First question, option C is correct. Question number 2, a radio station emits radiations of 400 kilohertz. The meter band of the station is. We know that the formula lambda is equal to C by nu. Lambda is equal to C by nu, and you will get 3 into 10 to the power of 8 by 400 into, we can get 1000, 10 power 3. So that we will get 750 meters we will write. 750 meters. Which option is present? Option B is correct for question number 2. Next question number 3. Which of the following electromagnetic radiation have greater frequency? Energy is directly proportional to frequency, inversely proportional to lambda. We know that R, M, I, V, U, X, gamma, C. Here lambda is maximum, here energy is maximum, and frequency also maximum, nu bar also maximum we can write. So here they asked frequency is maximum, they asked maximum frequency. Greater frequency is there, greater energy and greater wave number. So cosmic rays, X-rays. So X-rays will be the answer correct we can make. So A option is correct we can make. So question number 4. Question number 4. As closest approach, the distance between Mars and Earth is found to be 600 billion kilometers. When the planets are in the closest distance, how long it would take to send a radio message from the space, probably sent to the Mars from the Earth. So they asked you to find how much the time taken for the information to send. So here, question number 4. So we can write here, time is equal to distance by speed we will write. Now here distance how much given? 60 million kilometers. 60 into 10 power 6 into kilometers means 10 power 3 divided by what is the speed? Velocity of light. 3 into 10 power 8. Calculate how much it will be. 200 seconds. 200 seconds we will get. So 200 seconds, B option is correct for question number 4. Next question number 5. Two electromagnetic radiations have wave numbers in the ratio 2:3. Their energy per quanta will be in the ratio. We know that E is equal to h nu bar. E is directly proportional to nu bar. So we write E1 by E2 is equal to nu1 bar by nu2 bar. So that is equal to how much they given? E1, the wave numbers are given in the ratio 2:3. So energies are also in the ratio 2:3. Directly we can write the answer. Which option is correct? 2:3. Option B is correct. Option B is correct for question number 5. Now question number 6. Question number 6. A radio station is emitting the radiation frequency. So 2 into 10 power 4 hertz. If the frequency is doubled, they ask you to find. So here E is directly proportional to nu. So we can select the second option is correct. Energy per quanta will be doubled. So B option is correct for Question number 6. Now question number 7. The eyes of certain member of the reptile family pass a single visual signal to brain. When the visual receptors are struck by the photon wavelength 662.2 nanometer, if the total energy of the substance or waves is equal to 3.0 10 to the power minus 14 joules is required to trap the signal. What is the minimum number of photons that must strike the receptor is? Here the question is based on E is equal to x into hc by lambda. Already we discussed about this. So we need to find x value. X is equal to E into lambda by hc. We solved previously this type of problems based on book back questions and in-text questions also. So energy value given to you, and also Planck's constant you know, and velocity of light is given, and wavelength also given. So you can find the answer, that is equal to 10 power 5 you can get. 10 power 5 you will get. So which option is correct means 1 in 10 power 5, A option is correct. Question number 8. Question number 8. A photon of 400 nanometer is absorbed by a gas molecule, and then the molecule re-emits two photons. One re-emitted photon has a 500 nanometer. Assume that there is no change in energy of the molecule. Then the wavelength of second re-emitted photon is. So here the question is based on two photons are emitted with radiations lambda 1, lambda 2. So we can write energy is equal to E1 plus E2. So hc by lambda 1 plus hc by lambda 2 I will write. So we can write hc by lambda is equal to 1 by lambda is equal to 1 by lambda 1 plus 1 by lambda 2. They given here 1 by 400 is equal to 1 by 500 plus 1 by lambda 2. Lambda 2 we need to find. 1 by lambda 2 is equal to 1 by 400 minus 1 by 500. So we will take the LCM 2000. 2000 is the LCM we can take and we can write 500 minus 100, 100 will get. So we will get here 1 by 200 will get 1 by lambda 2. Lambda 2 is equal to 200 nanometers we will write. 2000 nanometers, sorry, 2000 nanometers we will write. So which option is correct? Option B is correct, we can write. Option B is correct, we can write. Now question number 9. Objective questions and all we need to solve very fastly. Question number 9. A green bulb and red bulb are emitting radiations with equal power. The current relation between the number of photons emitted per the bulb per second is. Here they given green bulb and red bulb. So number of photons emitted, Ng green bulb, Nr red bulb. Now here we know the relation between wavelength and number of photons emitted. So here energy of green is equal to energy of red. No? Energy of green is equal to energy of red. Number of photons emitted hc by lambda we know that. Hc by lambda g we can write. And nr hc by lambda r we write. Lambda r we write. Now here what the parameters we can get? Number of photons emitted in green bulb by number of photons emitted in a red bulb is equal to inverse proportional of wavelength. We can write G. Now what are they given? This is given, fraction is given less than 1. So we can write Ng is less than Nr. Ng is less than Nr. So which option is correct? B option is correct. B option is correct for question number 9. Next question number 10. A dye emits 50% of absorbed energy as a fluorescence. If the number of quanta absorbed and emitted are in the ratio of 1:2 and its absorption of radiation is a wavelength x, then wavelength of emitted radiation will be. Now here wavelength of energy of emitted radiation is equal to 50 by 100 into energy of absorbed we can make. And then here N1 Hc by lambda 1 is equal to 1 by 2 into N2 Hc by lambda 2 with available formulas. Lambda 1 by lambda 2 is equal to, we can write 2 by 1 into N1 by N2 we will write. So here 2 by 1 into N1 by N2 also given 2 by 1. So we can write 4 by 1. So lambda 1 is equal to 4 into lambda 2 we will get. 4 into lambda 2. Lambda 2 is given x angstroms. So 4x angstroms we will write. 4x angstroms we will write. Which option is correct? Option C is correct. We can write. Make it note that formula and the problem, and when the free time is there means you can check it back once again. 2 times if you see means definitely will get the answer. No need to go for confusion. Read the question 2 times and solve it. Next, question number 11. A wavelength of photon will have energy equal to average energy of photon with delta 1, lambda 1 is equal to 4000 angstroms, lambda 2 is 6000 angstroms. So here we need to calculate the lambda wavelength. Energy is equal to, we know the formula, 1 by 2 into E1 plus E2, net energy. So 1 by 2, 1 by lambda is equal to 1 by 2 into 1 by lambda plus 1 by lambda 2. So 1 by 2 into lambda 1 how much given? 4000 angstroms plus 6000 angstroms given. Now upon calculation we will get the answer 4800 angstroms. 4800 angstroms is present in B option. You can check it slowly, no problem. Don't go for fasting. We read the question 2 times and then practice the solution like this. Then you will get the answer easily. Okay? Don't worry that fastly doing the solutions means you can try to understand, you can copy and then try to understand and then practice once again. If you practice means the problems will also be very easy. Until finally we need to solve the answer like this. Then only you can able to solve in competitive examinations with less time. Practice and then definitely comes perfectness in the solving the questions. Next question number 12. Bond dissociation energy of BR2 is given 200 kilojoule per mole. The longest wavelength of photon that can break this bond would be. So Na to Hc is equal to given 0.12 joules. Now here the question is asked based on bond dissociation energy is nothing but E is equal to Hc by lambda. E is equal to Hc by lambda into N. Avogadro's number will write. Avogadro's number will write. So here that value is given 200 kilojoules. So 200 into 10 power 3 is equal to Na into Hc, that is given 0.12 divided by lambda. So lambda is equal to what we can get? Lambda is equal to 0.12 by 200 into 10 power 3 will get. So answer becomes 6 into 10 power minus 7 meters. So which option is correct? Option C is correct for question number 12. Option C is correct for question number 12. Next question number 13. Question number 13. The wavelength of photon having energy 1 electron volt will be. 1 electron volt will be. So here the formula to be used is lambda is equal to 12400 angstroms divided by energy. This is nothing but in electron volts given Einstein equation we can write. Einstein energy equation. So we will get the answer also 12440 angstroms because E value is given 1 electron volt. So this is given by Einstein scientist. That relation is very much important. Next question number 14. What is the answer for question number 13? Question number 13 answer is B option is correct. Option B is correct. Next question number 14. In the emission of photoelectrons, the number of photoelectrons emitted per unit time depends on intensity of incident radiation. We theoretical based question only. Option B is correct. Question number 15. A photosensitive surface receiving a light of wavelength 5000 angstroms at the rate of 10 to the power minus 7 joule second. The number of photons received per second is. The number of photons received per second. The question here. So the question is asked based on the formula E is equal to N into Hc by lambda. We need to find N value. E lambda by Hc we write. E lambda by Hc we can write. Energy is given 10 power minus 7 into 5000 into 10 power minus 10 divided by, what is the Planck's constant? 6.627 into 10 power minus 34 into 3 into 10 power 8. So we will get the answer 2.5 into 11, 10 power 11. What is the option correct? Option A is correct, we can say. This problem based formula we seen earlier in NCERT based question and book back question and text question also there. The same formula, but the values are different. So it is advisable to students to calculate earliest value of Hc value. What is the Hc value? If you find you can substitute it here. Directly you can solve the problem easily. Question number 16. In order to increase the kinetic energy of ejected photoelectrons, there could be increase in we can write a frequency of radiation. C option is correct, we can write. Question number 17. The threshold wavelength for ejection of electron from metal is 330 nanometers. The work function of photoelectric emission of metal is. So work function they asked. Work function is equal to h mu naught, that is equal to hc by lambda. What is Hc value? 6.6 into 10 to the power of minus 34 into 3 into 10 to the power 8 divided by, what is lambda given? Lambda 330 nanometer. 330 into 10 to the power minus 9 we will get. So upon calculation 6 into 10 to the power minus 19 joules we can get. So which option is correct? Option B is correct. So explanation may be very fast. But if you write the solution and solve that answer once again means it will be very easy for you. You must also practice like this to solve the answer within 1 minute in competitive examinations. You need to practice maximum times. Then it will be helpful a lot. Next question number 18. Last question. Question number 18. The ratio of wavelength of characteristics of the X-rays produced when iron Z is equal to 26 and scandium Z is equal to 21 are used as anti-cathodes. Then what is the ratio they asked to find? Here we know the formula square root of C by lambda, that is equal to most days experiment is given. Square root of mu is equal to Z into A minus B. A into Z minus B. A into Z minus B. One factor is given. Now here, what are the parameters are? Z value. So here we can write A value is 1, we can write lambda for iron by lambda for scandium is equal to atomic number 21 minus 1 by atomic number 26 minus 1 whole square we will write. So we can get 16 by 25. 16 by 25 will get. 16 by 25 will get. So here square root we will get square. 16 by 25 is answer. So which option is correct? Option C is correct. With this we completed the worksheet related to the problems. All type of models we covered. Don't worry, you practice these problems all. If you practice all those problems thoroughly, whatever the worksheet given, so in competitive examinations definitely you can solve all the questions. Thank you.